Hello everyone, welcome to Documented. In this video, I am going to explain about APB bus protocol. So for those who doesn't know what a bus protocol is, let me give a quick shot. So for example, every CPU, like your computer has an Intel chip, right? Every CPU has to be communicated with a peripheral like UART or GPIO or timer or whatever it is. It has to be communicated with a peripheral. So there are multiple communication protocols like UART or SPI or I2C communication protocols. But these communication protocols must be connected to the CPU, right? So this connection between the CPU and the peripheral is created by the bus. Bus is nothing but a channel between these two components to create the communication between them. So there are multiple popular bus protocols like you must have heard about the AXI protocol, AXI4 Lite, or those protocols are so popular. Among those popular protocols, this protocol is the APB bus protocol. So APB is a bus protocol that is also used with the AXI protocol. So APB is defined as the advanced peripheral bus. So it is mostly used with that peripheral bus systems. So I'm not going to be go more into the theory and I'm going to be actually more practical in this session. So it is part of the AMBA and used in the ARM architecture. It is the low speed peripheral bus. So there is a meaning for this low speed peripheral bus. So let me give you a quick thing. So here I'm going to tell how APB protocol is actually working. So here, imagine there's a CPU core here. It is connected by the AXI protocol. Like AXI is the main bus system here. If you don't know AXI, I'll be making a separate video on it. So, but just imagine AXI is high-speed bus protocol like APB, and this AXI protocol is connected to the APB bridge. So why we are using the bridge or why we are actually using APB? So AXI is high-speed bus protocol. Like for example, CPUs running at a higher speed, like 50 megahertz or 100 megahertz, for example. So our CPUs, like our actual Intel chips, are working in gigahertz speeds. So like this, CPU will be running at a higher speed. But this peripherals like an LED turning on GPIO, a timer, or anything like that will take multiple cycles to complete its task. So it is considered as low speed peripherals. To connect these two, the bus must be supporting both this high speed and the low speed. But AXI protocol is a fully high speed supporting system. So AXI is supported with CPU, but this low speed peripherals are connected with APB. So now you know why it is called as low speed peripheral bus. It supports low speed peripherals and connected with the high speed bus like AXI. So here it is like AXI is connected to the AXI to APB bridge, and this APB bridge is connected to the APB interconnects, and this APB interconnect will be connected to the actual APB peripherals. So now let's get into the actual APB protocol, how actually it works. So there are main 5 signals in the master side and the slave side. So basically we consider this part, this APB bridge and the interconnect as the master of the APB and this peripherals as the APB slave. So for here, master has this 6 signals as the major signals and slave has these 2 signals as a major signal. There are multiple other signals too, but we are just taking a good look at the basics and we will be going further deep into it later. So first, P clock. This is the clock signal. You actually know what it is. This will be sent from the master like the core or any clock generating signals. And this P reset for the reset signal. This P represents peripheral. So other than APB, there are like AHB protocols. That AHB protocol will be using like H clock. But here we are using P clock. So this P represents what protocol we are using. So P reset, P clock, and then P select. This P select is the one which selects what peripheral we are choosing. For example, here we have two peripherals like GPIO and ID counter. So we need to select which peripheral we are going to use in that particular time. So this P select will tell you which peripheral we need to select. For example, let's take this GPIO as 1. So and this ID counter as 2. So we need to select this between which peripheral we need to work on. So this P select signal will tell like 1. So we will be selecting this GPIO. If it says 2, then we will be selecting the ID counter. So this is how the P select works. And next, P data. P data will have the actual data what we need to write. So like for example, it may be 10, 20 or whatever data it is. And P write is the binary signal to tell if we need to write, then this P write will be high. If we need to read, then P write will be 0. Simple. And this P enable is the signal that actually tells that you can start the process. Like I'll be explaining it how it works. So for example, just imagine this P clock reset, P select will tell what peripheral we need to choose, and P data has the data, P write has the write signal. Like if it is high, we need to write. If it is low, we need to read. This P enable will tell you can actually start the process. I'll be explaining about this P enable real quick in this video. So coming to the slave part, slave has two important signals, P ready and P odd data. So P ready will tell that all the processes are complete and you can actually have the data. The data is ready. So P odd data will send the data signal. So it has the data like 10, 20 or whatever it is. That actually read from the peripheral. So when you see the example, you'll be getting it so easily. So now let's get to the next part. This APB protocol will have two phases, setup phase and the access phase. Setup phase will get the peripheral ready for the actual task, and access phase is the phase where the actual task takes place. So this is the state diagram of how things work in the APB protocol. For example, in the ideal state, it will be doing nothing, and the setup phase, it will be getting the system ready for it, and the access phase, the task will actually execute. So here we go. This is the setup phase. We will be having the P select signal high, P enable 0. And we will be having P address, the address where we actually have to write or read, P write data and P write signal. And in the access phase or enable phase, we can call it either way. In the access phase, we will be having the P enable high. So as you can see, the P select is high from the start of the phase, and we will be having the P enable only in the access phase. So in the setup phase, the interconnect or the APB master will actually give the right data and the right address we need for the actual task. And in the access phase, it will tell that you can start the performance. Like P enable will be high and it starts to write and it starts to provide the data. Once the data is ready, like it completes the write operation or it completes the read operation and it's ready with the data, it will set the P ready signal to high. So now you can see the waveform here and you'll be so clear now. So this is the P clock signal and there will be P reset and other couple of signals too. But this is the basic diagram, so I can explain you what actually happens here. So once the P select signal is high, so this P select signal will tell you which peripheral we need to choose. For example, we have only two signals here, so 0, 1. If there's more than two signals, we can have the vector based signals here. So in our system, 0 means GPIO and 1 means ID counter, or any of the peripheral that has the select signal as 1. So this part, this third signal, is the setup phase, where the P select signal is high, as well as the P data is ready and the P address is ready. So everything for the actual task is ready here. So next signal will be the access phase. So this fifth signal. So in this part, P enable will be high. So telling the system to actually perform the task. So once this P enable is high, it will take the data from the P data, P address, and perform the actual task. So there is P write signal to tell the peripheral to perform the write task. So it will write this P data in this particular address. For example, here 10. So this 10 will be written to the address of 5. Once the transfer is complete, like the write task is complete, the next signal will tell you that P ready signal will be high. Once the P ready signal is high, the master knows that the transfer is complete and we can receive the signal from the master as P value. So this is the master side signal. So this signal will be high once it receives the P ready signal. So you can see this is the setup phase and this is the access phase. So this is how the APB protocol works. So for example, I'll just show you how it actually works in a real system. So I'll show you a real system like architecture here. So this is an SoC architecture. So there's a core like an processor, your Snapdragon processor, anything like that. This core will be connected to an AXI wrapper and to connected with the AXI bus protocols. There's an AXI interconnects. This whole system is an AXI bus protocol. So this AXI bus will be connected to the other peripherals like SRAM, ROM, or anything other than that. And then it is also connected with the AXI to APB bridge. This is where our system comes in. So this will convert the AXI protocol into the APB protocol, and this APB bridge will be connected to the APB interconnect. This interconnect will be connected to the other peripherals like GPIO, ID counter, timer, or anything like that. To summarize, APB is an low-speed peripheral bus. It actually works with low-speed peripherals to connect it with the high-speed bus. And it has this major signals, and there are other signals too, like P-strobe, P-protect to protect the signals. And there are two phases, setup phase, access phase. And in the setup phase, the data will be ready and the address will be ready. And P-select signal will be ready to select the right peripheral. And there is enable phase or access phase. In this access phase, the actual task takes place, like write or read operation will be taking place. Once the transfer is complete, it will be sending the P ready signal and the master will send the P valid signal. So this is the simple explanation of the FPB protocol. In the next video, we will be designing the actual Verilog code for the GPIO that supports APB protocol. And in the further video, we will be doing the ID counter and we will also doing then AXI based videos. So if you are interested in this VLSI and embedded systems, you can just subscribe and like this video. And if you are more interested in VLSI and embedded systems, you can just go to learndia.com to get the full roadmap with an actual content to learn and get job ready for VLSI and embedded systems. And the interesting part is it has hardware resources and tracks for core roles like VLSI, RTL, embedded system with AI assessments and certifications. Other than that, subscribe for Dortmund Electronics and you'll be getting the notification for the next video where we'll be designing the GPIO for APB protocol. If you find this video useful, drop a like and comment down. That will be so helpful for me to make more content such as this. If you are into VLSI and electronics, subscribe. And if you want to learn more about such kind of topics, follow me on Medium to read about it. We are also building a Reddit community to share weekly updates too. All the links are in the description. Thank you.